Start just by talking a bit about test format stuff. So I have 10 total questions for the test. Like the first 3 questions, it's going to be like, I'm going to give you some data and ask you to write like a couple of different models from the data. So I might ask you for like a linear model and a quadratic model. And then to decide like which model would be the best one to use, and then to make a prediction using that model. So just like some of these later homework set problems, I have 2 questions about whether something's a polynomial or not, and if it is a polynomial, to give the leading coefficient and the degree. Yes, sir?
Are we reading your review packet?
Where there's no review packet for this chapter. I'll talk about what we have instead. Okay. I have 2 questions that are kind of like numbers 5 and 6 from the homework. So where you're given like 2 points basically and asked to write the equation for the line. I have another question that's, again, we're just building a model and using that model from some data. From set. And then I have a question where I ask you to determine the best type of model using a scatter plot. And this we talked about at the end of last class, right? Where I gave you those 6 pictures, right? So you'll just find the data set that looks most like each of these pictures or whatever. And then last question will be about determining if a prediction is reliable or unreliable. So let's review this concept here a little bit, because the homework quizzes, the reliability part weren't great. So what 2 things do we need for a prediction to be reliable? What was that, Corey? Accurate number. I thought somebody. Oh, Lucas. Yeah, so you need the model to fit. So if it's linear, the R value is close, or if it's not linear, the R squared value is close to 1, right? So the model fits well. What's the other thing you have to have then to get a good prediction? Anybody remember? Has to do with the input to your model. You have to be using interpolation, right? The number that you're plugging into your model has to be within the x coordinates in your data set, right? If you don't have both of those 2 things, do you have a reliable prediction? No. That's the gist of it. So those are the 2 things you'd want to check, is that your R, or your correlation, or your coefficient of determination has a good value, that you have your model is a good fit to your data set. And then 2, you're using interpolation instead of extrapolation. Everybody okay on test format stuff? Okay. Today is the review day, so part of that day you're going to be building your half sheet to use for the test. What kind of stuff would you want to put on your half sheet? Probably your calculator steps if you don't feel good about those, absolutely. I would put on, for sure, those pictures from the 2-3 notes, right? And then anything else from the problem set that you're like, ooh, I feel like that was kind of tricky. I can't remember what to do with this type of problem. Anything like that, I think, is good filler. Ideally, you would turn those in today. If you don't get it done today, you can always bring it by tomorrow morning or something. Everybody cool with that? Okay. The other thing that you can work on, there is no review packet for 12, but what I do have is I made a Delta Math for this. So the Chapter 12 Delta Math has like 5 types of questions in it. So you have like describe the type of correlation. There's just like a drop down, right? So that's easy. You have a strength of linear relationships questions. Come on, Delta Math. So here you're given like 4 regression equations, and they'll ask you for like the strongest negative relationship. Which one would that be? What number what's the only number I'm looking at for a question like that? So what's the only number I need to look at? Only care about the R's, right? Which R is going to be the one that indicates I have a strong negative linear relationship? The one for regression 3, because it's the one that's closest to -1. That's it. That's all I do, right? There's a question on linear regressions where you're asked to, or you're given some data set. You need to write your linear regression equation and then use it to make a prediction. Okay with that? Just all in the calculator. The thing you need to worry about, or that kids or what students were getting things wrong, was the roundings. So it's being very specific in the question on how they want you to round the coefficients in your model. And then 2, that you're being careful with the prediction. So here we're asking to estimate the calendar year. So you're asking to get an X value when the new cases are 604, when you're given a Y value. So you got to plug Y into your equation, then solve for X in this case. Sometimes you're going to be plugging in a Y and solving for X. Sometimes you're going to be plugging an X in to evaluate to get a Y. There's a power regressions equation. Again, all you're doing is typing your model in and then building your regression equation and making a prediction. Again, the predictions are kind of the same way. Sometimes this number will be an X, sometimes it'll be a Y. You should be able to read from the context of the question. And then the last one is just like regressions in general. So like this one asks for an exponential, and all they want is a model. So you just kind of type in your calculator and use the exponential reg to get it. Does that feel okay? Okay. If you have individual questions on stuff, I'm happy to answer that kind of thing. Just come on up and ask if you're stuck on anything or you have some clarification question or whatever. I'm happy to deal with that. If you have a makeup to do, like an old homework quiz or something that you want to take care of today, you could do that today. You could be making your half sheet. You could be working on your Delta Math. You could be finishing your problem set. I don't think there's probably a shortage of things to do. So get something out, be productive. Any final questions for me before I release you guys to kind of do your thing? Okie dokie. Get cracking, folks.